And we're back. Uh, just to catch you up, so in the last episode that was live, we were just playing around with ChatGPT and used that to make a basic orbital dynamics simulation in Blender. And it worked really good. And after a little bit of back and forth, we got that working quite well. So now, the next thing I want to do is have a separate text block which will pull information from to do multiple planets so that we don't have a conflict between trying to do multiple planets that might come out the same name or something, or me having to go into this and run it multiple times. I want to just define all those planets, run it once, and get all my orbits made. We could run into some trouble with animation here, but let's see what we get. Uh, the last last episode got cut a little short because I hadn't actually paid ChatGPT. I was just doing that all on the free version, which tells you you can get a lot done with it for free, which is pretty great. But I went ahead and paid him. It was about $20, and so we can continue playing around. So what I did, got him paid, and I said, okay, that's working great. Now I want to do this for multiple planets, just kind of like I explained to you. I just told that to ChatGPT. It's gone through and modified the code. Most of the modifications are up here at the top in the way that it's handling the inputs. It also suggested the text that I can use for the second text block, which is going to model the rest of the planets. Well, Mercury, Venus, Earth, and Mars at least. So, anyways, let's get started here. So, I just need to copy this block. I'm going to go over here, replace it with the new code, and then I also need, let's see, that text block. Let's see, it needs to be named, I guess, named text block. Grid planet data text block. So I need to make that text block be the right name. Oh, planet data. Let's see what this. Oh, planet data. I need to name it exactly like this. That's what it's looking for. All right. And we'll copy this sample data here. Put that in. So this is essentially comma-separated values, which is a real efficient way to get lots of lines of data into your code. So back over here, we're going to run this now. But first, let me get rid of that old stuff. Text, run script. Now, hopefully that is working. So it's kind of stalling for a minute. I think it has to calculate lots of stuff, which is why it's doing that. Hopefully it doesn't crash. Well, we'll see. Getting that beach ball. Beach ball makes me nervous. Although some of these operations can take a few seconds, up to even a few minutes sometimes. So what it's supposed to be doing is calculating the orbits for all those planets and then plotting the positions of all those in animation. I don't know, it's acting like it's pretty stalled. Let's give it a few more seconds. In fact, let's just comment to ChatGPT, say it's taking a long time. It's a number of planets, more processing time. Although my other runs were really quite fast. Let's see. Frame count. Yeah, those keyframe insertions. That's the thing that I think is taking the longest. Yeah, we could do interpolation, which I'm not sure I like that, but we'll see. The blender seems to be unresponsive. And what we ought to do is let's see if we can quit this. I'm gonna do a Command Alt Escape and a force quit blender. That's something that happens when you're working with crazy code in Blender. You might have to force quit it once in a while. So it's good to know how to do that. Control Alt Delete and go to your task manager if you're in Windows. Let's just try again. I'm going to do the same core code. So we'll copy that. Same core code. And then we're going to make, this will be planet data. But instead of all of them, we're just going to copy and put in there just Mercury. And let's find out if that's what it's choking on. I don't think anything up here is a problem because it should be skipping that line. But let's see what we get. Just one planet. Okay, that did finish. Get in there and take a look. Right click, horizontal shift, or split. Get a timeline. Yeah, let's see how it's... Oh, interesting. So that did... Okay, I think I see what our issue is we need a maximum frame count because for Mercury to go through its whole orbit, it needs that much time. Well, it's real slow. So we need a speed factor. So we need a speed factor for, let's say, a year. 1 year on Earth needs to be X number of frames. Oh, we got master number of frames. Let's see what this is up here. Time scale is 100. Adjust this to control overall speed. And then we need a max number of frames because that's making 25,000 frames for every planet. It's no wonder that it took forever. Okay. All right. So Let's get rid of that. And let's take and go back to our planet data. And we just need to have it get the scene. We can just define how long we want this to be and just say, yeah, I want... no, actually I don't want that. I will set that right after time scale, max frames. That should be good. Okay, so it's asking if we want these optimizations. Let's skip the optimizations for now. I ran it with one planet. And the code works. But it generates keyframes for 25,000 frames, which takes a long time. Let's set a master, or a maximum for the frame maximum. Right after time scale. So now we should get our frame max, then we can take and say how long we want this to be. Yeah, that should work. Let that get finished. Calculation. Yeah, in a future one, we should do like an n-body simulation and see if we can animate a bunch of masses. Okay, so added frame max. Okay, great. Let's see how we do. Okay, that, and then frame max. Let's set that to 1800. That'll be a minute at 30 frames per second. That should be a much more reasonable time. Let's go ahead and run that script. Way faster. Okay. Now is it scaling? It's interesting they're moving faster than that last run. This is a problem. We've got Venus is orbiting faster than Mercury. So that's wrong. And Mars here is orbiting even pretty fast. But Venus should not be going faster than Mercury. That's a problem. So something's wrong with the way those orbits are being calculated. Are they all trying to get... So their orbit speed relative to each other is not right. Oh, they all just took that long. Okay, so we need to go... We need to have this go relative to a year. I think that time scale... Something's wrong with the time scale. Okay, let's talk about that. Let's see, we need to set the time scale to be relative to Earth's year. And their planets might not complete an orbit during the animation to frame max. And that's okay. This could be a big... This could be a big change in the code. Or at least in the part where orbits are being calculated. That should all be the same. Oh, maybe it's in... Be in the, I guess, in the anomaly? Maybe? Not seeing a lot of changes? Let's see. Maybe I'm just not noticing. Okay, so Earth's orbit always takes whatever timescale is set to. Other planets are proportional. Excellent. Oh, okay. So P divided by the Earth's period. And that's okay. Great. Yes, thank you. Alrighty. See, we're just gonna delete everything. Give me a cube though. No, I don't want that. Yeah. We also need like a semi-major axis scale, and then go proportional to that as well. Anyway, probably did this already, but I forgot. Run script. Okay. Taking a few moments to get that. Should be. Not forever, though. All right. But it did make... Oh, I forgot to change that. That's fine. But they're all running slow. I don't like that. Let's... Yeah, that's... Okay, let's try this. No, we're still having a problem. It's still not working. So it had a little oversight in its last revision. So that's fine. We're gonna update. And for those of you joining us from home, we're just messing around with ChatGPT and Blender. And we're using ChatGPT to help generate a script that can take take orbital parameters for multiple planets and then model those orbits and animate those. So we're having a little bit of trouble getting it to behave just the way I want, which means I want it to follow Kepler's laws, which mean that the closer you are to the central body, or the heavy thing, like the sun, the closer you are to that, the faster your orbit is. And the farther from that, the slower you go. In the last session, a little bit earlier, we did have some great success modeling a single orbit. Even an eccentric orbit was really quite good. So we're working through a little bug right now, and my process for that is just to try to take my best guess at explaining what the bug is. I explain that to ChatGPT, and then it's modifying the code. All right, let's see how we do now. Copy that. Paste that in. Get rid of these guys. And make some changes up here. I'm just doing 1800 frames. Let's run it. All right, come on. Oh, they're going slow. So Earth's year should be scaling to 100 frames. That is not happening. But I do see Mercury going faster than Venus, which is an improvement. So that part's good. All right. Make this go a little longer. This will take a moment to calculate. Right now we're kind of brute forcing the animation by putting in, see all these keyframes here, just putting in a ton of keyframes, keyframe for every position. Not super elegant, but it gets the job done. Oh, that's obnoxious. So it's scaling the way it's animating until it gets to the max frame. So we do have a scale factor problem with time. That time scale should be, like Earth should take 100 frames to do one orbit. Under what we've talked about previously with ChatGPT in this episode. So let's go complain about that. Okay. So the orbits are now Kepleronian, but Earth's orbit is not following the time scale. It seems... actually, I don't even know what it seems to be doing. Let's just see what it comes back with. Does not honor. Okay, we might have a problem here. If it's hard coding for Earth, I think we might actually need to be a little smarter about this and have it scale for the semi-major axis of 1, like 1 AU. And then we need to scale how big that is in Blender. Alright, I'm gonna try it, but... Actually, I'm not gonna try it. I think I want to do... On second thought... Let's not hard code Earth. But instead... make the time... What was it called? Time scale against work relative to a semi-major axis of 1. And that'll work for Earth, but a centric orbit might get kind of different. But let's see what it comes up with. So down here in the anomaly. Yeah, actually it's... Oh, this line 64 could be an issue. Oh, yeah, there's our hard cut, so that needs to go away. There we go. And there's more hard coding that goes away. Good. Okay, yeah, it's a little shorter to boot. All right. I think it still might be using frame max, but that's one thing at a time, I guess. Oh, whoopsies. I forgot to change that frame max. Still doing like 10,000. Well, it still was fast enough, I guess. Alright, moment of truth here. Earth is still taking way more than 100 frames. Are they still relative? Yes. Yeah, okay, I gotta complain about that. You know what? Let's double check something. Yeah, okay, Earth's is showing at 1. So it's not just garbage in, garbage out. It's AI slop. That's what we're doing. Could get a real coder in here and probably fix this a lot faster than me and ChatGPT. But we're just playing around on a Sunday morning. All right. Earth is still all right. Let's see, I made my complaint. Oh, well, you need it. It's not eating its own dog food. You have to kind of rub its face in it in order to get it to fix itself. All right. Did you change that? All right. Once more, although I don't want it to go so long, so let's see. Oh, they're not rendering. Run script. It's still too slow. Too slow for the time scale. Oh, I see the issue now. You're updating. Okay. One more try. Give me 5,000. Run it. Little beach ball for a moment. Okay, come on, fingers crossed. No. What is the deal? I'm just gonna say nope. See what it does. We. I like how it's we. Well, I guess that's how I'm talking to. All right, you, me, and ChatGPT making some AI slop. We're doing the definition of insanity. This one, this one might be different. Okay, run it. Ah, no. No, now that's making the outer planets orbit faster. That's no good. Man, starting to feel like I want to scrap it. Hmm. That's worse. Now the outer planets are orbiting faster than the inners. Up in our music. I don't know. You're right, I'm right. Yeah, still being scaled incorrectly, causing the outers. I'm sure. Reference planet completes its orbit. Oh, in timescale times 250. Well, that might be on me. That's okay. You know, some of this is being more careful. A more careful reader is a human being. So let's say timescale is 1. Give me that now. Oopsie. One more run. There we go. Okay. That's progress. Now we just need him to continue orbiting. Okay. That's great progress. All right. Cool. What is the... Oh, I don't know why we lost our music. It might be some OBS thing. Well, maybe you didn't lose it. I don't know. I can't hear it anymore. Check on something. Yeah. Looks like it's supposed to be playing. Anyways, I'm new to streaming. Maybe I'll play music in a different way. Alright. Actually, no, I don't want to copy that. Say, okay. Good progress. Speeds look right. But... And I was just reading the... I was using the timescale wrong because I'm dumb. But we're not going to tell it that. Okay, the speeds look right, but the planets stop when they complete their orbits. So we want to keep orbiting. Keep orbiting till frame max. Oh, okay. Let's do cyclic. Maybe that'll work. Okay, so cyclic F-curve modifier. I want to see what that ends up looking like. Let's do that. I've used those modifiers before, although with this, normally I would use it. Maybe it works. I don't know. That needs to be small. That needs to be... That's fine. Actually, go ahead and... Yeah, let's see what happens when I let it be that. 10,000. That was fast. Huh. Oh, and they keep going. Okay. Pretty cool. Okay, that works. I want to scale this system in Blender space. How about a scale? scale factor based on semi-major axis. Okay. This would be a little bit bigger update. That's cool. Updating. All right, cool. Get rid of all these and replace with this. Scale factor of 10, so we'll put Earth's orbit at 10. And let's go. 1 was good. Where'd my empties go? That's pretty good. Let's add in a rambunctious comet. Semi-major axis of 20. Eccentricity is going to be pretty high. Like 0.8. Everybody else's eccentricity is pretty low. Those are close to circular except for Mercury. Its orbit is not going to be precessing, which is a minor problem. But, you know, this is pretty good for just throwing something together. Okay, inclination. Give me some incline. Give me a 20-degree incline. And I don't really care about that other stuff. So that can all just be 0. Omega 0, little omega 0, big omega 0. Period. So I would still need to know something about about a real comet. So I'm going to make this comet's going to be a rogue that has thrusters that orbits way faster than it should. Well, we'll let it be something like that. Okay, so I got my name, I got my semi-major axis, I got my eccentricity, inclination, little omega, big omega, and period, which is totally just made up. So let's see how we do. Oh, this is an invalid thing because I put a period there instead of a comma. Whoopsie. Let's see if we can fix that. Hopefully we get a comet object this time. Error. What was that? Name's not defined. Why? I've done the wrong number of things. I'll just copy. We're going to copy Mars, but we're going to make it different. Oh, did I try to run that from the wrong place? That might have been what I did. Oops. Okay. Try it again. We do have a comet. Where's my comet at? There it is. I'm screaming in. Woo! That was cool. That's nice. Okay, good. Well, I could put in some real comet data there, and that would make this even better. But I tell you what, I am gonna get ready to go to a meeting, and I'm gonna leave it there for now. So, for those of you that are watching at home, an hour or later, sure appreciate you. Thank you very much, and we'll catch you next time with a little bit more noodling around with Blender. Looking forward to it. Take care.